Hello everyone, welcome to this video. In this video we shall see question from June 2014 consisting of 4.75 marks. Right? This question is from AbstractAlgebra. Let f of x be the fourth degree polynomial and they are saying p is some prime number. Then f px denote the corresponding polynomial with coefficient in zpz, that is the integer modulo p, right? Then they are asking whether f2x is irreducible over z2z, right? Whether it is irreducible over rationals, whether f3x is irreducible over z mod 3z, and f of x is irreducible over z. So out of these four we need to tell which are irreducible over the given fields, right? So let us see. For the first part they are saying f2x. So firstly we need to calculate, this is the given polynomial f of x, right, which is the fourth order polynomial. So let us calculate f2x first. What is that? It is the polynomial whose polynomial corresponding to this polynomial f of x, such that the coefficients of this f2x, they are reduced modulo 2, right? That means if we have coefficient 1, that means you will calculate this mod 2. So when you divide 1 by 2, you will get the remainder as 1. So this is 1. So next coefficient is 3. So when you divide 3, when you calculate 3 mod 2, that means when you divide 3 by 2, you will get the remainder as 1, right? So here we have 1. Again, when you divide minus 9 by 2, you will get the remainder as minus 1. And then when you divide 7 by 2, you will get the remainder as 1. When you divide 27 by 2, you will get the remainder as 1. So this is the reduced polynomial f2x corresponding to the given polynomial f of x in integer modulo 2. And the only elements in integer modulo 2, they are 0 class and 1 class, right? So now looking at this polynomial x raised to power 4 plus x cube minus x square plus x plus 1, this is an irreducible polynomial because a polynomial of this form is irreducible when the given p is prime. So notice that we have all the powers up to 4. So the next power would be x to the power 5. So p here is 5, which is prime. So this is an irreducible polynomial. Therefore option A is the correct option. So now let us look at f of x. They are asking whether the given polynomial, this is irreducible over q or not. So now we have this result, mod p irreducibility test. It says that if p is any prime number and f of x belongs to zx with the degree of fx as greater than equal to 1, then the polynomial reduced in zp, which is fx modulo p, then if this reduced polynomial is irreducible for some p, this p could be anything, right? And the degrees are same, in that case we say that fx is irreducible over q. So now you already have calculated this thing, that you found p is equal to 2 such that the corresponding polynomial f2x with the same degree 4, right, this is irreducible over z mod 2z, right? So integer modulo 2, this f2x, the corresponding polynomial is irreducible. Therefore by this result the given polynomial f of x is irreducible over q, right? If you wanted to have a detailed explanation for this test, you can visit the link given in description, right? So according to this test, by mod p irreducibility test, we say that the given polynomial f of x is irreducible over q, right? So option B is also the correct option. So now come to option number D. They are asking about f of x is irreducible over z. Now we have a result that irreducible over irreducibility over Q implies irreducibility over Z. So now, just now we have obtained that the given polynomial is irreducible over Q. That means it is also irreducible over Z. Therefore, this option is also correct, because it is quite obvious that we have a polynomial f of x which is irreducible in Q. That means in a bigger set we cannot factorize it. So we have the set Q, right? And inside the set we have some other set of integers. Now, if you cannot factorize a polynomial over here with much large number of coefficients, how can you factorize the same polynomial here in the smaller set, right? The set of integers. So this result is quite obvious. So this is irreducible over set of integers as well, right? For the option third, they are asking f3x is irreducible over integers modulo 3. So that means we first need to reduce this polynomial over over integer modulo 3, right? So this is our given polynomial. We reduce it like in the same way. The first coefficient is 1. When you divide 1 by 3, you will get the remainder as 1. So it is 1. The second coefficient is 3. When you divide 3 by 3, you will get the remainder as 0. So this coefficient is 0. When you divide minus 9 by 3, you will get the remainder again as 0, right? When you divide 7 by 3, you will get 1 as the remainder. And when you divide 27 by 3, you will get 0 as the remainder. So our polynomial is reduced to this form, x raised to power 4 plus 1. So now clearly you can factorize this polynomial. X, you can take x common, so it would be x into x cube plus 1. Therefore, this polynomial is reducible over integers mod 3, right? So this is not irreducible. So option C is not the correct option. So the only correct options are A, B and D. Well, that is it for this video. Thank you for watching.